So my name is Aanchal Varma, and I'll be presenting my research on SAS-BERT, which is a BERT model for sales and support conversation classification, where we use a novel multi-objective pre-training framework. Our agenda for today will be going through the objective about the introduction on the research problem, the related work that has been done, our experimental setup, the methodology that has been used, the results that we see as part of our research, and conclusion. So before that, let me just quickly go over myself. So my name is Aanchal, and I work as a lead data scientist at Freshworks, India. I have about 5 years of experience in the field of NLP, machine learning, deep learning, language modeling. And prior to Freshworks, I have also worked with Samsung on NLP and speech problems. My other co-author, Chetan, he's a director of data science at Make My Trip. And prior to Make My Trip, he has worked as a senior staff data scientist at Freshworks and has also worked on various startups and B2B SaaS companies and in India. And he has about more than 10 years of experience in the field of machine learning and NLP. So I'll be presenting our work today. So let me start with the objective. So our idea is to introduce a SAS-BERT model, which is a BERT-based architecture tailored specifically for sales and support conversations. We see that sales and support conversations are very different sort of conversations where a lot of agent and customer emails thread continues on a regular basis. We try to enhance the performance of BERT architecture on these domain-specific datasets, which are very different from the general datasets on which these language models are trained on. And we try to achieve results which are comparable to fine-tuned LLMs, such as ChatGPT, Falcon, Llama. But we also try to show the advantage of using these tailored BERT-based architectures in terms of fewer parameters, faster training times, and suitable for single CPU inference. So our idea here is to provide prediction probability distributions for sales deal outcomes with good explainability. The sales support conversations are related to sales deals which are going on a regular basis. And all these sales deals either have a positive outcome or a negative outcome. So all the sales conversations that are related to a positive deal, which eventually converts and brings money for the company, have some sort of positive context in them, while all the sales conversations which are related to the negative deals, which do not convert, where the customers are not willing to buy a given product or a given service, have some sort of negative context with respect to the conversion within them. Our idea is to look at the email context and the support conversations context and try to predict the probability of closure from the context to understand how well the email context captures the sales deal. So although LLMs tend to understand this natural context very well, and we have seen that with the advancement of ChatGPT and various other large language models, understanding the textual context, whether it is a positive direction in terms of sales conversion or it is a negative direction in terms of sales conversion has become very easy. But these LLMs have their own disadvantages. They come with very slow inference time, heavy memory consumptions, because these are large language models with billions of parameters, and they also lead to high costs and time consumptions and are not very ready to go into production where it can scale for millions of customers. These LLMs are not very impressive on domain-specific tasks as well, where SaaS industries or industries where there are a lot of sales-specific conversations going on, which have custom keywords and which have some certain sort of documents and formats on how these work, they require accurate sales deal outcome prediction. So in order to solve this problem, we explored BERT-based fine-tuning techniques, which are tailored for sales and support conversations. So we propose a two-stage BERT architecture, where in the first stage, we introduce a novel pre-training framework. And in the second stage, we introduce a fine-tuning framework where we augment the data with GPT. The first BERT pre-training framework involves smart ways of masking and smart ways of performing next sentence prediction, where it tries to understand the context of our sales conversations in a much better way, while our fine tuning framework aims to predict for classification tasks and tries to tune the BERT model in order to capture whether a deal could be a positive conversion or a negative conversion based on the text which is given in the email. We try to get results which are comparable to the fine-tuned LLMs such as Falcon, Llama, and even compare it with GPT fine-tuned versions and ChatGPT. And this SAS-BERT has significantly fewer parameters as compared to LLMs, since this is a BERT pre-trained model which has only about 110 million parameters as compared to LLMs or ChatGPT based variants which has billions of parameters. This is also available to train faster, and this is also suitable for a single CPU inference. While our proposed solution is divided into two different tasks, the first task is a masked language modeling technique, which is a variation of the standard masking technique, where instead of randomly masking tokens, we mask some relevant tokens which are identified using a separate naive Bayes model. In addition to masking these chosen tokens, we also mask a span of tokens rather than masking a single token around it in order to predict for the masked token while pre-training on a domain-specific dataset. Along with this, masking on a span of tokens around the relevant tokens which have been chosen by a separate model, we also run a variant of the next sentence prediction task where we put in email pairs, which are agent and customer conversations, and we train the model on these conversation pairs. This entire pre-training framework enhances the capability of BERT to understand on sales conversation specific context and to completely nurture the capabilities on predicting the deal closure probability. Our second task is fine-tuning this pre-trained framework on classification data, where we try to even augment the training data using clean dataset from GPT. We try to take in the capabilities of GPT 3.5 to enhance the unstructured sales conversations and convert them into much cleaner versions and augment them to our original data in order to provide better context for classification. We also try to fine tune it on a classification task where the emails which are associated with a positive deal which was converted are assigned as 1, while the emails which are associated with a negative deal which did not convert are assigned as 0, and hence it is trained for a binary classification task. There has been a lot of work that has been done in pre-training BERT on domain-specific datasets. Models such as SkyBERT, PubMedBERT, and BioBERT, they focus on training transformers from scratch, and they also focus on building separate vocabulary for domain-specific target. On existing BERT, certain architectures like FinBERT, LegalBERT, they have been pre-trained where instead of training BERT from scratch, they take in the existing BERT-based models and embeddings and try to pre-train those models on domain-specific data. We try to incorporate similar techniques as used in FinBERT and LegalBERT, where rather than training BERT from scratch, we take in the BERT embeddings and BERT model weights which are available, and we then try to pre-train our model on our domain-specific dataset using smarter techniques. There has also been work done on extending BERT architecture by augmenting its embeddings with certain domain-specific vocabulary. And models like SPAN-BERT and NBMLM-BERT, they take a dig on smart masking techniques. SPAN-BERT has been launched, which takes in the idea of masking a span of tokens, along with performing certain additional tasks to understand how, instead of giving a single token, we can actually mask a continuous span to allow BERT to understand the context in a better way. There has also been some work done on conversational dataset, which are available online, such as STORD-BERT and CS-BERT, that try to pre-train BERT on conversation-specific dataset, which is very different than the standard dataset that Wikipedia dataset that's available online, because this contains information that is directed to a single person and it is very highly unstructured. We try to look at some of the examples of our actual conversation data set that we have used in order to do pre-training and fine-tuning. This sort of data set consists of sales and support conversations, which spans thousands of years, different businesses from the CRM aspect. This data is at a sales deal level. So all the emails which are associated with a positive sales deal are tagged as 1, while all the emails which are associated with the negative sales deal are tagged as 0. So if you could see, we have a prospect email, which is a customer email, which tries to understand on the product or on the um, requirement of what they're trying to buy. And then there's an agent email, which tries to answer on those requirements, that this is how the pricing goes and this is how you can we can meet your requirements, and if they're willing to buy the product, they can schedule a call, and this is the sort of discount that we offer. We also try to feed this sort of unstructured information into GPT to also try to augment this and shorten this and get a much enhanced and compact with much cleaner context version. We also try to perform some sort of LLM model evaluation, where we evaluate models like Llama, Falcon, and various other BERT-based models for classification tasks. We also fine-tune some of this with LoRa on domain-specific data. So models such as Llama, Falcon, they are fine-tuned with LoRa on our domain-specific data. And we also compare this with ChatGPT, which is not fine-tuned and evaluated as it is. Since these LLMs can only give you a textual output and a textual input are needed, we prompt it to return yes or no and then evaluate it with F1 as a final metric. So when we try to classify BERT, we try to generate probability values to understand how close is that email in predicting a sales deal closure. And while we try to use LLMs for our comparative evaluation, we provided prompts and try to answer the question on whether this could lead to a positive deal closure, or this could not lead to or this email looks like a positive email, or this email looks like a negative email when it is related to a sales deal. With the answer coming out as yes or no, we try to convert those into 1/0 and then compare it with F1 as our final evaluation metric. Our multi-objective framework involves pre-training BERT and then fine-tuning BERT on our domain-specific data. So our input pre-training task takes in the random set of tokens and uses a separately generated relevant sort of tokens and masks those tokens specifically. So how our entire architecture flows is, we train a naive-based classifier on our sort of emails and then try to, using the featured importance techniques, we try to generate relevant words which are very crucial for our entire domain-specific data. And from this, we were able to generate close to 25,000 relevant words from our entire corpus of 8 million conversations. Now, these 25,000 relevant words which are available in our domain, we try keep it as a separate set. And while we started pre-training, we tend to use this relevant keywords as an input. And then in an entire context, we first try to mask those keywords and mask spans of data around those keywords. So rather than masking a single keyword, we mask an entire span for it to understand the context in a much better way. And then once this is masked, the span of token is masked around the relevant keywords which have been identified. It goes in for the pre-training task, which is masked language modeling plus next email prediction, where next email prediction data is generated using our agent customer conversation pairs, which are available in our sales deal conversations data. Once this pre-training is completed, we save in the model weights, and then we try to fine-tune the BERT model on top of these model weights. And we try to attach a classification layer and try to identify whether these emails could lead to a positive deal closure or a negative deal closure. Along with about 400,000 original emails, we also augmented about 20,000 GPT generated clean emails, which could attach and provide additional context in order to enhance the fine tuning. So our entire flow uses a naive-based classifier to generate conditional probabilities, which are assigned to tokens and determine their importance. So important tokens like help desk, omnichannel, demo, which is very relevant to SaaS conversations, are chosen. And while we perform the span masking, we try to mask spans of text around these tokens, and we identify the span length from a geometric distribution skewed towards the shorter spans. Once we tend to mask this data, we also perform next email prediction, and we pair this as a joint loss function and try to pre-train our BERT model. Our fine-tuning setup is, as we discussed, it also uses augmented GPT 3.5 clean dataset. And then we try to, and this sort of dataset is mutually exhaustive. So this is not included in the pre-training or in the important token generation part. We have separate datasets for all sorts of combinations, and then we try to evaluate our model after this fine-tuning setup. So from our results, you can see that we have performed various experimentations on LLMs such as OPT, Bloom, GPT-3, with various versions of GPT-3, Falcon, and Llama, which are not fine-tuned. And we have also compared it with some fine-tuned versions of these LLMs. So we have fine-tuned OPT, Bloom, various versions of GPT-3, and also Falcon and Llama, which are fine-tuned with LoRa, and then try to compare the F1. Along with this, we have also compared our versions of models with BERT models evaluated after fine-tuning. So BERT, without pre-training, BERT has only been fine-tuned on some same data set, which has been used for fine-tuning. And we have also compared Roberta, XLM Roberta, and other BERT variants on the same evaluation data set. So our first version, which is SAS-BERT A, which is a smart pre-trained model, which has been fine-tuned without GPT augmented data, is compared against various other fine-tuned LLMs. While our second version, SAS-BERT B, which also includes the GPT 3.5 augmented data for used for fine-tuning, shows almost comparable results to LLM Llama, which has been fine-tuned. And we see that fine-tuning Llama, which is a 7 billion model, takes in a lot of memory consumption, a lot of time consumption, and it is also very difficult to productionize it and scale it to millions of customers. And we can see comparable results, which are much smaller version of our SAS-BERT, which has been pre-trained on a very small amount of data, which is only about 8 million emails. And it also takes much lesser time and much lesser CPU inference usage. So in and all, it can provide you better results. We also compared this performance across industries since we had the customer conversations ranging from different industries. So we compared it with data ranging from software, e-commerce, financial services, and various other industries. And we see that the largest gains are obtained in software as service and e-commerce industries, which form a major part of our pre-training data set. So in conclusion, we highlighted the drawbacks of LLMs, that they take in a lot of slow inference and they take lots of times to train, and they need huge GPU and huge memory based devices in order to productionize them and scale them for millions of customers. And we proposed a BERT pre-trained architecture, which is a comparable alternative in terms of evaluation results, and it is also easy to fine tune, easy to launch as an inference, and has very faster inference time as compared to the LLMs. We detail our BERT-based architecture for customized for sales and support conversations, where it identifies relevant tokens which are involved in sales and support conversations, tries to mask them, enhances the entire context of email pairs by performing a next email prediction task on taking in the agent email versus the customer email, and show improved performance over all the other versions of models. And we also plan to expand this architecture to use voice data and chat conversations, and also various other open source conversational data sets to see how our model can perform against the open source LLMs that are available. Thank you.